Good morning to everyone. I'm Dr. Sumi MS. The name of the course is Electromagnetic Fields, and today's topic is Lorentz force equation from Unit 3 Magnetostatics. On completion, the students will be able to define what is Lorentz force, determine Lorentz force equation, and also solve problems in Lorentz force equation. Lorentz force equation. Lorentz force is the sum of magnetic and electrical forces experienced by a charge when charges are moving under the influence of a magnetic field. They experience forces on them which cause them to sometimes change their direction. The forces of these individual charges become a force on the conductor carrying them. There are a lot of applications of this particular phenomenon. All the motors that are employed in many devices work on this principle. Magnetic field and Lorentz force. Consider a point charge q which is moving with velocity v and is located at or at a time t in the presence of both electric field E of r and magnetic field B of r. Both of these fields apply some force on the charge under their influence. The force on the charge due to the influence was first given by Lorentz. The formula for this force was derived by Lorentz on the basis of rigorous experimentation that was done by Ampere and others. The force on an electric charge q due to both of these fields is given as F is equal to q times E of r plus V into B of r, and this is called as the Lorentz force. Looking at the formula, the relation between the electric field and the force which charges experience under its influence is known. In the case of force experienced under the influence of the magnetic field, the following observations are made. It depends on the charge q, velocity v, and the magnetic field B. In the case of negative charge, the direction of the force is reversed. There is a vector product between the velocity and the magnetic field, and the direction of the force is perpendicular to both of the quantities. In case velocity and magnetic field becomes parallel, then the force on the charge will become zero. That is, the magnetic force on any charge is zero if it is not moving. That is, velocity modulus of velocity v is equal to 0. This figure shows the direction of the magnetic force acting on a particle of charge q. Problems on Lorentz force. Q1. Find out the magnitude of the force experienced when the unit charge is kept under the influence of 5 Newton per Coulomb electric fields. The force on the charge is given by F is equal to QE, and substituting the value of Q as 1 and E as 5, we get the force on the charge as 5 Newton per second. Find out the magnitude of the force experienced when a 5 Coulomb charge is kept under the influence of 25 Newton per Coulomb electric fields. The force on the charge F is given as QE, and substituting the values of Q and E, we get force as 125 Newton per second. Find out the magnitude of the force experienced when a 5 Coulomb charge is moving at 10 meter per second under the influence of a 25 Newton per Coulomb electric field. The magnetic field of 10 magnitudes is perpendicular to the direction of the electric field and velocity. Find out the magnitude of the force that is experienced by the charge. The force on the charge is given by F is equal to Q times E plus Q times V cross B. Substituting the values of the charge Q as 5, E as 25, and V as 10 and V as 10 cross sine 90, since it is perpendicular to the direction of electric field and velocity, and we get the force as 625 Newton. Question 4. Find out the magnitude of the force experienced when a 10 Coulomb charge is moving at 10 meter per second under the influence of 5 Newton per Coulomb electric fields. The magnetic field of 5 magnitudes is perpendicular to the direction of the electric field and velocity. Find out the magnitude of the force experienced by the charge. The force on the charge is given by F is equal to QE plus Q times V cross B. Substituting the value of Q as 10, E as 5, and V as 10 and B as 5 cross sine 90, we get the force F as 550 Newton. Quiz questions on Lorentz force equation. Describe about Lorentz force equation. Find out the magnitude of the force experienced when a 5 coulomb charge is kept under the influence of 25 Newton per coulomb electric fields. Find out the magnitude of the force experienced when a 10 coulomb charge is moving at 10 meter per second under the influence of 5 Newton per coulomb electric fields. The magnetic field of 5 magnitudes is perpendicular to the direction of the electric field and velocity. Find out the magnitude of the force experienced by the charge. Thank you.